In 1964, two radio engineers at Bell Telephone Laboratories in Holmdel, New Jersey, Arno Penzias and Robert Wilson, were calibrating a large horn antenna originally built for satellite communication. They had a maddening problem. No matter where they pointed the antenna, north, south, day, night, summer, winter, a faint, persistent hiss of microwave radiation arrived equally from every direction. They checked every possible source of error, rebuilt connections, accounted for interference from New York City, even climbed inside the antenna and scraped out pigeon droppings, suspecting the bird's nest was generating thermal noise. The hiss persisted, identical everywhere, constant, unexplainable. What Penzias and Wilson had detected, entirely by accident, was the most ancient light in the observable universe, the cosmic microwave background. For the first 380,000 years after the Big Bang, the universe was opaque, so hot and dense that photons couldn't travel any meaningful distance before slamming into free electrons and scattering randomly, a blinding fog of ionized plasma filling all of space. Then, as expansion cooled the cosmos past roughly 3000 Kelvin, electrons slowed enough to be captured by protons, forming neutral hydrogen for the first time. The fog cleared, and the thermal glow of that 3000-degree plasma, filling every point in the universe simultaneously, was released to travel freely in every direction, forever. Those photons have been traveling for 13.8 billion years. Cosmic expansion has stretched their wavelength by a factor of roughly 1,100, shifting them from visible orange-red light into microwaves. The CMB temperature today, 2.725 Kelvin, less than 3 degrees above absolute zero. The coldest measurable remnant of a universe that, in its earliest moments, reached temperatures of trillions of degrees. A thermal afterglow, stretched and cooled across 13.8 billion years of cosmic expansion into the faintest natural signal ever measured. And now for a cosmic perspective moment that deserves a pause. Those photons are striking you right now, physically, literally. Approximately 400 cosmic microwave background photons occupy every cubic centimeter of space in the universe. They stream through whatever room you're in at this moment, arriving from every direction at the speed of light. You are bathed in the oldest light that exists, the afterglow of the Big Bang itself, and you cannot see it, feel it, or sense it without a radio detector. The universe's first photograph surrounds you constantly, and it is completely.
Like, if this was interesting, hit the subscribe for more and turn that notification bell on. Also, our full video on this was posted recently. Check it out on our channel profile now.